Yeah, g'day and welcome back to my channel. This week I'm taking a little break from modernising my lathe and I'm going to use it to do something productive. So let's get to it. Now, long-time viewers of this channel know that one of my workmates, Nicos, is still the #1 fan. During some time in the UK, Nicos picked up a few characteristics. One of them is, of course, the hats, but even worse is his attraction to the spawn of the British automotive industry. Now, while the ownership of a classic Mini may seem bad enough, it's really the attraction to the Morgan three-wheeler which showcases this perversion worst. Now, it seems along the way, Nicos picked up a few friends with similar handicaps, because last summer, 4 of them took their Morgans to drive around France, but only 2 of them made it back to Austria without mechanical failure. And that brings us to today's project. It seems the Morgan 4+4 drives its radiator fan off the water pump pulley. They just bolted this flange adapter onto the bell of the pulley and then bolted the fan onto that. As you can see, this design was not without some issues. From what I heard, the pulley came loose, they bolted it back on, but then further down the track, the whole thing shat itself. You're looking at some of this corrosion down in the fracture surface. Some of it looks a bit rounded over. I'm kind of guessing that the fatigue started somewhere down in this part and that the damage on the other side of the flange is more just a destructive disintegration when the fan hits something. The fan itself is steel and probably like 1/18 of an inch thick or so. You can imagine it probably damaged more than just the aluminium cooler to look like this. I did ask Nicos to provide photos of the destroyed cooler, and since he wasn't able to provide photos, I told him he needs to bring one of his cars around with his cooler and we'll smash it just for footage. Now, to get the show back on the road, the owner bought a new water pump, and I'm guessing from the paint job, a used fan. So he assumed you'd just need to buy that adapter, but unfortunately, this doesn't fit. And that's where I come in. So they've increased the diameter by about 2 millimeters, up to about 2 15/20 of an inch. I'm going to assume that they increased the diameter in response to these fatigue failures. So there's a couple of jobs I need to do. I need to make an adapter flange, one hopefully that won't come loose and fall apart, and I need to bore out the fan to fit. But I also really don't like the design with just 2 bolts through the side holding that flange on. What I think I'll do, make up a new flange. Since there's a lot of surface area, I'm going to use Loctite 648 as the main bond there. So to make sure I've got a good surface to bond against, I need to mount this onto a mandrel and just skim off to clean off whatever coating that is and give me nice clean cast iron. So the first course of business will be to make up a mandrel. Nothing too special, just a shaft in the lathe with a journal here that's reasonably closely fitting to my pulley and a thread on the end to clamp it in place. Right, enough talking. Let's crank up the Schaublin. First off, we home the machine so it knows where everything is. Okay, that's the machine homed. Okay, that complicates things. I just realized when I hooked up all the pneumatics, I cut the pipes for the pneumatic input to their final length. So I can't use pneumatics until I get this stuff installed, which rules out doing this job with collets. So I guess this all has to come back off. That's a shame because I was looking forward to taking advantage of the repeatability of collets. Oh well, dialing in a 4-jaw is also no great burden. I won't bother going into detail on dialing in the 4-jaw. Seems there's a dozen different videos on that already. This is going to be a nice and simple little toolpath. Just 2 tools, the first of which is a normal turning tool, and the second is going to be an insert threading tool. Okay, didn't quite have clearance, but should have given a little more clearance at the end of the thread. The insert chipped. So I just lost my tip. So second attempt. And I've switched around the threading tool, and I'm going to take a little bit more off the shoulder this time to give us a bit of clearance. Okay, let's go. Right, so let's see if that thread's going to fit, or we need to adjust the tool path a bit. It's very close. Let me just put a spanner on it. I'm definitely not conforming to the norm, but yeah, certainly not far off, huh? Okay, that thread is so close, I don't think I'll change the tool path since I'm only doing one of them. I'll just finish it off with the, run a die down it, just to clean up that last little bit. Yeah, it's really very close to finishing. Like cutting it mostly with the lathe and finishing off with a die gives you the best of both worlds. It gives you a very straight thread because the lathe doesn't have any problems with the tool wandering. The die's in good condition. It gives you a very nice thread with like intolerance thread. With that done, I now need to move it out further. I just wanted to turn the thread with it nice and short in the chuck, just to stop deflection. But I will now turn this with a bit of extension, taking nice light cuts, because hopefully then this pulley will turn nice and concentric. And this is an even simpler tool path, just using the normal turning tool. Okay, so it came out pretty much, as I said, I thought it would come out at about 15.95, it's 15.93. If I now polish off those surface finish, it should be just about perfect. Yeah. So this shouldn't fit, it should be about 1/10 over. Yep, that's too tight. I'll just use the emery cloth and bring it down. The first bit goes quite quickly because you're taking off just the tops of the... Okay, that's gone down 2 1/100ths. Another 6 to go. Whoops, I forgot to put a piece of paper down to keep any emery off the ways of the lathe. Let's try that. Oh yeah, that's a nice fit. Woohoo! The question is whether this thing actually runs true from manufacture. Yeah. I mean, it's not terrible. We'll put the clock on it, but it's not terrible. 1.5 to 2/10 of a millimetre of total run out. I'll just touch off and then go in 1/10 and then do a feed rate move back away. I have to go in 2/10 to get that to clean up. Yeah, we're only cleaning this to make it glue, so I think I'll leave it at that. Yeah. Well, that finishes off this part. The next thing I need to do is work out how thick to make the new spacer. Now, unfortunately, the pumps are not identical. The change in shape of the impeller is not really relevant to what I'm doing, but also those pulley housings weren't identical. What I need to work out is the location of this flange relative to this shoulder on the inside. Means that this distance between that shoulder which locates it and that shoulder which locates the fan needs to be 2.45 millimeters. So the final thickness of our flange needs to be 25.95. I guess we can call that 26. Now the old flange didn't go all the way down to here because it has this like top hat section, and rather than threaded holes to mount this fan, it used nuts on the back, but there wasn't enough clearance at the back for the nuts so that the bolts were angled, and when tightened the nuts put nasty little stress concentrations in the radius here. Not a good design at all. At least two of the nuts holes have cracks in them. Well, maybe all of them. Now, hard to know whether those were just part of the final destruction or whether they were already in there. Yeah, it looks like they were all cracked. So the decision was made with the owner that instead of doing this stepped design with a nut behind it, just make this a solid flange going all the way back and use screws without nuts. The Loctite, which is going to mount this, it needs a 5/100th to 15/100th gap. So I'm aiming for an inner bore 1/10 under this. So we'll aim for 69.58. This is a 100mm stock. I'll just polish the outside with some Scotch-Brite, leaving the full diameter. I'm going to need a pretty generous chamfer to avoid this radius. I'll do a chamfer out to about 80mm. So next, what's the bolt pattern on this thing? So I'll just check all the holes are roughly the same size. 53.2 and also 53.2. While I would prefer to turn this adapter here on the Schaublin, I only have side mounting tool holders. I don't have any way of mounting a boring bar at this point, and therefore I'll do it on the Boley. Now bore it out. This lathe has got an automatic traverse which kicks out with this knob. It can also auto kick out as it runs up this ramp. So let's adjust that and see how it works. Now I want it to kick out after about 26 or 27mm. There's a scale on the side here. Roughly there is where I want it to kick out. And now if I move the saddle, so if I engage the feed there and then move the ramp till it kicks out, we must be somewhere close. Okay. So I'll just see where it kicks out, and I can fine tune the depth using the top slide. Right, with the top slide dial zeroed, I'll just move my tool out beyond the work so it can't hit anything. Put a mark it where the target is. Right, now we can see where it kicks out. Okay, so that kicked out a little early. I want to go slightly beyond the 26, so that's about 1mm beyond. Okay, maybe that cut was a little bit too aggressive. Bit of a bird's nest there. Okay, so I'm beyond my minimum depth of 26, that's good. Once I get closer, I'll use a bore gauge. With 1 millimeter to go, it's time to set up the bore gauge. Okay, so I'm measuring at 0.17, and I want a gap that's 1/10 larger, so I'll go to 2.7 and lock it. And this micrometer can set the bore gauge. This may not be the greatest bore gauge ever, especially seeing as I bought it at some surplus place where I paid per kilo. It doesn't weigh much, so it didn't cost me much. I lent this to my mate Jörg so he could measure his Schaublin spindle housing, and he replaced the standard dial gauge with a micron reading gauge. Okay, that tips out too far. Maybe I can adjust it in, otherwise I'll have to switch it. That'll work. Now I just need to get it zeroed. Yeah, 1.3, 1.25 to go. $79 100ths to go. That's 1, 21 plus 8 is there. If I've done this correctly, at the end of this cut I should have exactly a ½ millimeter to go. Okay, we're showing about 94 microns to go, because that's my target 0 up there. But that doesn't agree with the direct measurement. Looks like it's double. Because here I'm looking at 69.55. So why is this giving twice the reading? I reset the bore gauge against the micrometer. Now, according to the dial gauge, I'm about 2 100ths under my target. And that's in my target range. That gives me a gap of about 8 100ths. And there we have it. Kind of a nice loose sliding fit. Just put a chamfer on that. While it is fun playing with the lathe, it's time to go to the mill. Once this part's all strapped down nice and securely, the next thing is homing the machine. You have to do this each time you first turn it on. I really like this hydraulic tool release. It's super convenient. Next up, I need to touch off on the part and find its center. Nikolai Owens gave me a 3D probe from Heimer which would speed this process up, but it needs to be pulled down and serviced, and I just haven't got around to it, so I'm still using the Starrett touch-off tool. It's kind of slow, but it does do a nice accurate job. Next I need to set up my tools. With a known length tool I have to tell the machine where the top of the work is. I just use an old broken 16mm end mill shank and roll that underneath the tool while adjusting the Z height until it just slides under it. Okay, with tool 3 loaded, I'm now 16 millimeters above. Better get a magnet. Now, while the spot tool I'd already set up before, I'll have to set the offset for this drill because I've only just inserted it. Having set the height of the work to a known tool, now I can go through and set the length offset into the tool table for any tools I've just loaded into tool holders for the first time. This wiggling back and forth of the spindle of the Maho is the way that it makes sure that the gears are engaged while it's doing a gear change. If the tool approach looks a bit jerky here, that's because I'm using feed override and also holds to make sure my toolpath is safe and correct. Well, other than setting that countersink a little deep, that looks good. Well, next up, need to tap the holes. Let's do that on the mill as well. Now, the Tapmatic's really a tool from the manual machining world, and most CNCs don't need something like this because they have feedback of an encoder of the spindle position, but the Maho doesn't have this. So this Tapmatic makes it a nice, safe way of tapping. The Tapmatic needs an anti-rotation device. I think I've shown this a couple of times before. Unfortunately, that device goes into this hole, and this hole is normally used by the lathe. I really need to come up with a better solution for this so that the lathe can stay where it is, but oh well. I'll just take the lathe up out of the way. This setup's getting pretty close to the Z height limit of the machine. I'm at the top of travel and I think I've got 15 millimeters of left. Cutting oil in there. Setting the feed rate for the 6mm tap is really easy because it's got a 1mm pitch. Therefore, feed rate equals RPM. So with the Maho spindle turning at its slowest speed of 80 RPM, I need 80 millimeters per minute of feed. Here I forgot to put the little rapid move up to change direction quickly. There's a little gearbox inside the Tapmatic, so it backs out at 1.5 times feed speed. So I've got it set for 120 millimeters per minute of retract. I hand coded this and I forgot to put a rapid between the rest of the holes. That's it for that setup. Now we need to go back to the Boley to part it off and then clean up the other side. I need to part this off at 26 millimeters. I'll cut it off a bit long so I've got something to face off once I've flipped it. I just realised when I changed the top slide angle, I didn't line this back up square, so the tool's probably going in at an angle like that. Oh wow, during editing with this top-down view I saw just how badly off it was. Lucky I didn't break the tool. I think that's a bit much. I'll finish it off with a bandsaw. This 16-inch DoAll bandsaw is such a handy tool. It chops through aluminium in no time. Now let's go back to the Boley to face that piece off and put on a big chamfer. Now the last operation is just a big internal chamfer here to clear the radius. Should be about 80 millimeters. No, still a ways to go. Make sure these threads are deep enough. This is the last operation I need to do on the spacer, so let's move on to the last piece of the puzzle, which is the fan. Right, chopped a bit of wood just to pack this up. Once again, touch off. I made this brick-like pendant, which is pretty useful, but unfortunately I temporarily wired it to the wrong side of the machine. And yeah, temporary's been pretty permanent so far. I really need to rewire this across so it's next to the controller. I think I'll bore this out with the manual quill, so I have to unlock it here. These cheap Chinese boring bars are a bit tricky to set up accurately. You gotta keep a bit of drag on the gib screws and make sure you only ever turn them one way because of course there's backlash in the screw. On this first pass, I'll go down and cut a bit of wood to give it clearance. So what does it all fit like? Pretty darn nice, I'd say. Give it a bit of a degreasing. Especially that bore. Get the screw threads clean as well. I'll lock like those in as well. Well, let's glue it together and the job can be finished. Five minutes till it sets up, overnight till it's hard. Now this pulley is supposed to have a woodruff key driving it, but neither the old one which came off, nor this one, as new, had the woodruff key in it. Nicos still has to source that woodruff key before he returns it to the owner. If you'd like to see footage of this installed, please put a comment in the comment section telling Nico to hurry up, get a woodruff key, and take some video as he installs it and as they test drive the car. Thanks for watching.